Hello everyone, my name is Jaisha and I am from TE Electronics in DG College of Engineering. Today I'll be showing you how to set up the Kyle Mu Vision 5 software and we'll also run some addition and multiplication codes in 8051. So let's get started. First, open the Kyle Mu Vision software. Create a new Mu Vision project and save the file. In the dialog box, search for P89B51RD2. Click on OK. Right click on the target 1 folder, select options for target 1. In the target menu, change the frequency from 40 to 11.0.592. In the output, check into create hex file. In the debug option, click on limit speed to real time. After applying the settings, click on OK. Create a new document by going to File New or Control N. Type the code for the program and save the doc file with .asm extension. After typing the code, save the file in the name of the project and type the extension .asm. You can see the color of the code has changed. After saving the file, right click on source group 1 and add existing files to source group 1. Select your .asm file and add it. After that, close the pop-up window. Now you can run the code after you have translated and built the code. So first translate the code. It will show you the errors and warnings you have in the code. Then build the code and then by going to debug and start stop debug session, you can run the code. So now let's see the first code of adding two hexadecimal numbers. The ORG instruction is used to declare the origin or the starting point of the code. The move instruction is used to move a data type or address into a register. Add instruction is used to add the value contained in the two registers. The end instruction is used to denote that the code is successfully ended. So now to run the code, you can select the F11 button. You can also click on F5 to run the whole code directly. The left side of the screen is the register bank which shows the values of the registers. We have added 30H and A0H. The addition of these two numbers is D0H which is finally stored in the R1 register as you can see here. So now let's move on to the second experiment, that is multiplication of two hexadecimal numbers. The multiplication of two 8-bit numbers is a 16-bit number. In this we have used the mul instruction which is used to multiply two numbers. Mul instruction is only used for A and B registers. The final product is saved in the R1 and R2 registers. So as after we have run the code, we can see the R2 register is E1E and the R1 is 00. So the product of 30 into 0A0H is equal to 1E00H. In the next experiment, we are going to multiply two numbers but without using mul instruction. So again we have selected the two numbers as 30 and A0H. Now we need to go in the for loop where in this we need to run the code such that if the in this first we clear the A register and then add R0 register to it. Then if there is a carry, then we increment the R3 register. Then we make sure that this loop runs for R1 times so we can get the multiplication of 30H and A0H. JNC is the command which is used when there is jump if no carry. The INC command is the increment command which is used to increment a register value. DJNZ is a conditional loop command instruction. It decrements the register value mentioned and checks if it is 0. The next, we're going to blink the LEDs in the port 1. For that, we need a logical analyzer video. For the next experiment, we are going to blink the LEDs in port 1. For that, we would require a logic analyzer window, and in peripherals, we need to show the port 1 in input-output ports. So we need to blink the LEDs in an alternate pattern for 1 second each. So now we need to write a delay program for that. So this is the delay program I've written. So now let's run it. You can see that the LEDs are high for 1 second and low for 1 second. To check that, you can click on one part of the LED and then in this you can see that the delta is 0.9 seconds, that is approximately equal to 1 second. Also in the parallel port 1 you can see the alternate blinking lights of the port 1.